Grade 11s and 12s, this is the easiest way I've found to remember special angles, and this works the best for most of my students as well. Some prefer the lower table, but most of them prefer the protractor over here, because in trig, we have our Cartesian plane unwinding from 0 to 90 to 180 to 270 and back to 360. The reason this works is because we can draw our protractor like we would inside our first quadrant. From there, we write our 90 where our 90 is, our 0 where our 0 is, then we have our 60, 45, and 30 over there. What we are doing is we're getting our coordinate pairs based off of this. And what we know is that the x value for 90 is 0 over here. We just put a square root for each coordinate pair over here, and our starting point that we just have to remember is square root of 4 is this way. But what is quite nice is as we move right 1 unit, we have square root of 1 for the x value, but we also move down 1 unit for our y, which means we have the square root of 3 over here. This repeats from step to step, because as we move right again 1 unit, we have the square root of 2 for our x value, and we move down 1 unit for our y value, and we have the square root of 2. This then repeats again, moving right 1 unit, square root of 3, moving down 1 unit, square root of 1, and then one more time, moving right 1 unit, square root of 4, moving down 1 unit, square root of 0, which means that the 0 and 90 are opposites of each other in terms of x and y. What we just have to know then is r equals 2, and we have all the x and y coordinates for our special angles and our radius as well. This helps us even more, especially if we're using shelter your rear, because x rays tan your exterior, because then we have sine equals the y over the r, which we can just plug in from here, cos equals the x over the r, which we can just plug in from here, and tan equals y over x, which we can just plug in from here. So this is all we need for special angles. For any questions, we're seeing any forms of 60, 45, 30, 0, and 90 as well.